All right. So we talked about earlier that the semester that a picture has an interpretation, it has a meaning, and then there's the calculus that can tell us that information. Increasing and decreasing, what in calculus can tell you that answer? The first derivative, and in terms of concavity, the second derivative. All right, so increasing, we knew that had to do with being positive, and negative if it's decreasing. How about concave up? Positive, right? And then concave down. All right, so decreasing, we also meant visually, that was drawing with our hand going down, and the two situations where we had decreasing were A and C. These were both increasing. How about which were the ones that were concave up? A and B, good. And these were concave down. Alright, so increasing and concave up, so increasing concave up was B. Right? Decreasing and concave up was A. Increasing and concave down, D. The last one is C. Alright, the calculus. So decreasing, so let's say going through each one. A, increasing, the first derivative had to be positive, so that's either 1 or 2. And concave up, the second derivative also had to be positive, so you should have 3 for the first one. Right? Decreasing and concave up. Decreasing, negative first derivative, and concave up had to be positive, so you should have 4 right here. Increasing and concave down. So increasing and concave down 2. Right? The last one should be 1, decreasing and concave down. Any questions with this one? Alright. The second one, you're given an equation. We just care about the relative max or min, or the local maxes or mins. And regardless of how we got there in terms of the test, it still required us to get critical points. So we would get the derivative, 3x squared minus 12. We solve that equal to 0 or undefined. We don't really have anything for undefined. There's no division by 0 or square roots or anything like that. And when you solve it equal to 0, what did you end up getting? Plus or minus 2. Good. Alright, first derivative test, how do we check if these critical points are the local max or min? Yeah, minus 2 and 2. Check where it's increasing or decreasing, so we use the first derivative to tell us that. I'm just going to write this out in factored form. You didn't have to. If you put in a test point, that should still work. So we'll get x minus 2x plus 2. Alright, anything smaller than minus 2, what would you get for the sign of the first derivative? Careful. So like you'd get positive, right? Because you'd have, if you plug in minus 3, this would be minus times another negative, so it'd be plus. Alright, anything between minus 2 and 2. Yeah. And then bigger than 2? Good. Alright, so then you would say, I asked you all in the, as I handed out the test to give the coordinates, but we had a local max at x equals minus 2. You would plug in the minus 2 to get the y coordinate. So you should get if I put in minus 2, I'll get, yeah, thank you, 20. And then local min x equals 2, yeah, negative 12. Good. Alright, let's say that we didn't want to do the sign chart. We didn't want to plug in 3 points as test points to figure out the answer. We talked about how second derivative tells us concavity. If I have a min, I know that the concavity should be concave up, or that the second derivative should be positive, and if it's concave down, at my critical point, it meant that it was a local max. So the other option was, let's look at the second derivative. What would you get for that here? 6x? And you just care about the sign. So we want to check x equals minus 2. What's the concavity look like at that critical point? In terms of sign, it's negative, right? Concave down. So if I'm concave down at my critical point, and it's concave down, what is that going to be? Local max. Bless you. It's going to be a local max. How about at 2? What would the sign be of the concavity? Positive, concave up. Meant that critical point is concave up there, it's a local min. Right? And you'd give your answer like we did here. Are there questions with how to use second derivative tests?
I have a question.
Yeah.
I get it like obviously it's equal to 0, so that'd be 0 and you take test points on both sides. It shows what's on both sides of the inflection point, which means would that still work or not?
No, because that just tells you the inflection point. It doesn't tell you how to check if those critical points that we found earlier are local maxes or mins. Right? If you found the inflection point and you did the sign chart with the second derivative, that's exactly what you just did. You just found inflection points.
Right.
You didn't
But
find
it's just showing that they're going opposite ways. So at that inflection point, so wouldn't that be the same thing?
No, it's not the same thing because that tells you nothing about that critical point if it's actually a max or a min. You found where it changes how it's opening up or down, but that's it.
So if we do a sign chart for the second one, we know we're not ever going to be
No. Alright. Is everyone clear on why not? Because remember we said an inflection point an inflection point is a place where it changes from being concave down to like concave up or vice versa. This is an inflection point. Has nothing to do with a local max or a min. Oh, sorry. Yeah. What I'm saying is that's an inflection point that doesn't tell you anything about a local max or a min. It just tells you where you change from going open, up, or down. Another example, like an inflection point, I could have something like this. That's an inflection point. It tells me nothing about maxes or min. Alright, the back page. So we had a limited amount of time. I just gave you all the information, asked you to sketch the graph. But part of that meant I had to know what that information meant. So I'm told that when x is 0, y is equal to 6. That's a given point that I have to draw. But other than that, I can draw any function that does what I'm doing. That's continuous, doesn't have any sharp corners. There's a derivative everywhere. I'm told that the derivative is less than 0 for these x values and greater than 0 for those given x values. It's a nice, clean, compact form. We said we could take a step back and just organize that information. The trade-off places I have seem to be minus 6, 0, and 6. And the first derivative being less than 0 is telling me that it's negative or decreasing. Greater than 0, positive or increasing. Okay. Alright, so from that, what do you know about those trade-off points or the critical points? Good. Exactly. Local min, and this is a local max. Okay, how about the second derivative? The trade-off points that I seem to have are at minus 3 and 3. The sign of the second derivative tells me how it's going to open. Being greater than 0, I know that it's positive for these given values, or it's concave up. It's negative between minus 3 and 3, meaning it's concave down. What that also tells me is that these are inflection points. And then I can sketch my graph from there. All I need is any graph that does the following thing. So I just for sure I need to have f at 0 equals 6. Okay. And then after that I can pick. Okay, so at -3 and 3, that's places where I'm going to have an inflection point. -6 and 6 are the lowest points on my graph. So it might, let's say we put -3 right here, and let's say we did it in the same place on the other side. That's my inflection point. I know that at 0, that's my local max. Let's say we decided to have -6 like somewhere over here. Actually just be 0 and 6 at 0. That was my local min. Okay. So I'm drawing with my hand going down up until -6, and it has to be concave up, it has to be opening up. After -6, I have to draw with my hand going up, but it's still concave up until I get to my inflection point, which says, okay, now you have to turn down until you get to where I have to stop increasing at 0. I stay concave down as I decrease. At my inflection point, I'll switch to concave up. This is my lowest point, and then it will continue concave up as it increases. Yeah, question?
Do you get points for shape?
Yeah, I mean, I'm looking for the graph if there's something like that. Yeah. And then question.
So just as a question, mine across the x-axis, it wasn't starting up, so I was starting down at 0.
Yeah.
Is that still right, or is that wrong? The way I drew it in, like it's coming from 0 across the x, like from the x.
Like that? As long as your hand is going up and it's concave up. Yeah. Yes.
Isn't there horizontal asymptote that y equals 6? Isn't that what the first one means? F of 0 equals 6?
No. This says when x equals 0, y equals 6.
So that's your y-intercept?
Uh-huh. And then any other questions with this? All right. I'll be posting these on Blackboard. We'll go ahead on to the next topic. So we spent a lot of time how to get local extrema or local or relative maxes or mins. So the next section, 3.3 and 3.4, have to do with this idea of optimization. All right. Yeah, sorry. Okay, optimization is no longer saying that finding a local max or min is not really good enough. I want to be able to answer the question of what is an absolute maximum or minimum. Maybe I want to minimize my costs for my business. What is the absolute max and or min of my model? Okay. So we talked about local extrema. We know that we could have multiple local mins or local maxes. It just meant they were the lowest point in their neighborhood or the highest point in their neighborhood. So if I'm talking about an absolute max or min, then what am I looking for? The highest point out of the whole thing, right? So okay, min lowest point out of the whole graph. Okay. In this example, do I have an absolute maximum? No, how come? Right, it goes to infinity on one side and minus infinity on another side. So a lot of graphs over the whole graph, they don't have an absolute max or min. Right? Okay. Due to the fact that I will have whatever going on in between, but something like that happen on the edges. Could you all think of a graph that does have an absolute max or min over the whole thing? Okay, x squared, right? So an example of a graph. Alright, so we said an example of that would be something like, bless you, like x squared, right? How many local extremas does this have? Just has one, right? It's always decreasing from one side and increasing from another side. So I guess we can make that observation, we can make that note if it ever comes up in a model that we have. We can make this note that if our model has one local max or min, has only one critical point that is an extreme point. If it has only one critical point that ends up being a max or min, then it is the max or min point. Then it is the absolute max of our model. Okay, so we do have that if it comes up with whatever we're working with. If it just has one critical point, it's a max or min. I'm done, I know that it's the absolute in that case. Alright, but aside from that special case, how can I come up with an absolute? So aside from this scenario, okay, instances where we have absolute extrema are where we, instead of allowing our graph go over the whole thing, look at only certain windows of it. So if we limit our graph, instances where we have absolute extrema are if we're only looking at specific windows of our graph. So this paper that I keep flipping through back and forth, I have copies for you all to kind of walk you through that idea. Okay. So our question is then, if we are looking at a specific window, where do the absolute max or min happen? so that's our question. All right. So if I decide to not look over minus infinity to infinity, I only want to look at specific x values. Namely, let's say I want to look at from x being minus 3 all the way up until 0. We said the absolute max is the highest point, the absolute min is the lowest point. Where does that seem to happen in this window when x is minus 3 to 0? Okay. So I'm starting from here. This is the y value. It goes up, it goes lower, and then it goes all the way up to almost minus 10 here. What's the highest point in this window? Right there. Okay, so that's seems to be my absolute max. Okay. Where does the absolute min happen?
Like minus 2.
Somewhere over here, right?
Yeah.
Okay. Okay. All right, so it happens that in terms of the absolute max, it happened at the end point of my window. The absolute min happened at like the local min inside the window, right? Okay. Happened at endpoint. The absolute min happened at the local min in the window. Okay. What I'd like for you all to do is with your partner up, and then just kind of try to look at different windows pictured of this graph, and then label, like circle how we did here, where the lowest point happened and where the highest point happened. And just like how we wrote here, absolute max happened at endpoint, absolute min happened at the local min. Go ahead and write that for each of those. So try to look at different windows and come up with where the absolute max or min happened. So take the next couple minutes to do that. Please partner up with someone and we'll talk about that.
Doesn't matter really what side of the graph we're going on.
Doesn't matter, but you just go from one x value to another x value.
On the same graph?
Yeah, so I gave you like 4 copies. You could do a different one.